Hello everyone, Alton Smith. I had a young fella, Jason, I'd sent a secondary to and some some 1UF 10,000 volt capacitors to try to help him out on making his Tesla coil, and he asked me what was the correct way to wire it up, so I told him I would try to do something and where he could see what it is. So I'm going to give a brief rundown of my 4-inch Tesla coil and see if this will help him out. Now this is the diagram of the way it is wired up. I'm going to try to get in a little bit closer. It pretty much shows the correct way, the way I wired it up. Now the caps I sent him are these right here. I sent him 4 of these. They're 10,000 volt at 1 UF. Now my spark gap I make like this. Buy most of this stuff at Lowe's or Home Depot and make it pretty easy. They're not hard to make. Now, here is my 4-inch Tesla coil right here. This is the one I'm going to give a rundown on and sort of get in close where I can try to show everybody what I did and how I did it. The leads come out of the 12,060 milliamp transformer. One side gets connected on this one here. The other side gets connected on that one right there. It's pretty simple. This side over here comes out and goes around to the capacitor bank. If you can see it in the back, and I'll try to refocus, the back wire goes up and goes to the base, the beginning of the primary. That is the secondary right there going down to ground on the other side, which I will show that in just a minute. This is the capacitor bank right here, and I will try to refocus this thing again. They're run in series. I think there is 2, 4, 6, 8. There's 18 capacitors, and there are 2. Jesus, I forgot what these are. I think they're 2,000 volt, but I can see. Yeah, they're 0.22 microfarads. And there's like 19 of them in series. There's bleeder resistors on the top of each one of them, and they're just connected and looped in series. I just use regular standoffs from the thing. That's a piece of Lexan. I drill the holes in and soldered them, and if I remember right, I used silicone to hold the capacitors pretty close to it. Let me move this table around here and zoom out all the way. Now from the back side, you can see where it comes into the everything over here on the back side. That's where it hooks up to the primary and goes down to there. This is the ground lead right there that goes to my ground rod, and it goes up there to the center of the secondary coming down. This is the transformer, and everything over here is just bolted down on standard. The capacitor bank over there, you can see where it hooks up and goes straight up to the main of the primary. Now the back end of the capacitor bank down here, this wire goes up here to where I tune it. Now my primary is, this one wasn't done as good as most of them. This is my first one I ever did, and I didn't really do it as good. I use clamps like you hold cable wire to a wall to hold the 1/4 inch copper tubing down. I mean, it works good, but it doesn't look nowhere near as good as it could have been. But being the first one, it's the way I did it. I learned better after I went along how to do it. Now the secondary goes up to the toroid up there, and it's connected up there with standoff and everything. Basically it's a single transformer, a double spark gap, 19 capacitors, and that's about the general run of it. Spark gap I think is set at 98 thousandths gap. Pretty plain Jane setup, not hard to see. Just a row of capacitors and hooked up in series with bleeder resistors. Now this is a better shot of a spark gap made just like that. I hope this is focusing because it don't look like it is on my camera. That's similar. It's a 120 volt fan and spark gap. This again is the actual diagram of it. Jason, I'm going to take a picture of this and email it to you. When I done my next coils, I don't do the way I did that right there. I didn't care for the way I did it, and I learned better. To be in fact, my bigger Tesla coil over here, I use 1/2 inch Lake sand to hold it up, and done a whole lot different setup on it than I did the other one. And even my solid state one over here, I found out masonite works best to hold. It's much easier to work with and everything. I just got to where I tried to make a better thing than I used to the first time around. I was learning, and it's one of those things where you just learn as you go. But this one works okay. I mean, it's nothing spectacular. It does okay for a 4-inch with a single transformer. I'll turn the lights off real fast like, and oh well, one more thing. This is my control panel I make to operate all my Tesla coils with, all my big ones, the spark gap ones. I even use it on my solid state one to monitor the amperage it pulls. Don't have to, but I do. So I will turn everything on, turn off the lights, and we'll do about a 30-second thing in here, and I'm going to let it go. Okay, that was quick enough. Jason, I hope this gives you an idea of how to wire one up a little better, because it's close proximity of it. It's not that hard, but this is the diagram one more time, the way I wired mine up. That's the capacitors you should be receiving, and you can make this kind of spark gap up, but I think you're using a rotary spark gap, and which is fine. Alright man, I hope you can get an idea from this video. I hope you get a better idea of how to do this and how to wire it up to be right. If you don't and you got any questions, call me and I'll be glad to try to answer it. And I thank you very much, and I do hope anybody watches this will at least get something out of it and enjoy it. Have a good one.